Hello. Hi, everyone. Welcome to Thumbtack. Before that, I give you guys a very brief introduction of myself. My name is Yunliang Jiang. I graduated from University of Illinois in 2012, and then I joined Twitter as a software engineer as well as data scientist. And I left Twitter in October 2014 and joined Thumbtack as a software engineer. So yeah, welcome here. Today, I will give a brief discussion about mainly something about my PhD thesis and a little bit of my current work, which are always highly related to the machine learning stuff. This is actually brief skeleton of my PhD defense. That presentation cost me 3 hours, and I shrink the PowerPoint to like this 10 minutes thing. So I think it's not that easy. Try to let you know my work, but it's good to go. My topic will be clustering and comparing information extracted from personal health messages. So my research interest focusing on data mining, machine learning, and NLP on specifically medical informatics area. We see a lot of online communities recently in the healthcare domain. For example, WebMD, Yahoo Health and Wellness Discuss Group, and also MedHelp, Patients Like Me, this kind of very good websites and communities offer users, customers, patients, especially doctors, a very good platform and a place for them to communicate with each other or to grab useful medical information for their information need. But there are always a lot of challenges for these discussions for online communities. First, this kind of information are very noisy, contains a lot of useless stuff. And also compared with the real medical records, this kind of messages are pretty unstructured, which is very difficult for people to digest. And the third thing is this kind of online personal messages are kind of lack of connection with the real clinical practice. However, these challenges makes researchers have the opportunity to effectively analyze and reorganize the rich source of personal health messages by applying advanced data mining or IR and NLP techniques. Here is some of the summarization of my work. I try to define this whole project or whole problem into 3 different layers. The first layer is the data. The data we look at, which contains the very rich personal medical information. Messages are coming from a lot of different channels, especially some of the voice messages. And the other is the object we try to research on. There will be full kind of text or some of the drug information, disease information, or even the symptom description. And also a list of the techniques we try to apply. And I know most of them are very related to the machine learning, however, it's just not the full list. So for my PhD topics, it's I combine 3 of the things together. The first problem I try to solve is personal message classification, which applies Yahoo Group's health and wellness data using the classification technology and analyze the whole text. And the second problem I try to solve is the patient-drug outcomes integration, which use additional sources, some of the topic modeling and clustering techniques, and combine some of the drug information, the medicine information. And the third topic we are talking is the CER, hypothesis prediction. CER, maybe you guys not really familiar with this term. It's a medical term called comparative effectiveness research, which is in medical area is very important topic. Try to compare different treatments or different meditations on the same person or the same group of people to see which one has a better which one has a better performance, and compare the effectiveness and the other sides. And we use the MedHelp and the other disease information, and also using the semantic analysis, statistics testing, and opinion mining techniques. And also there are some areas and data I didn't touch to, but I know some of my following PhD friends at school are still working on that. They kind of using some of the voice messages and they try some of the social network analysis. That could be the future directions. So next, I will just quickly go through the three topics or three problems I solved. The first is multi-class classification in online personal health messages. We try to understand and try to get the useful information from the online personal messages. However, some of them are kind of useless. And we know we want giving a set of the medical messages. We try to separate them into three main categories. The first one is the news, is about the latest information, some news about some of the progress of the treatment. That kind of information is part of important, but it's not the thing we really want. We try to see the personal information. So the second one, user comments, which will be our target. And the third one is the spam, which mostly advertisements. The approach is like we train a multi-class SVM classification on a set of the training data using the combination features. For example, the term appearance and the lexical and the semantical features. We train our classification work very carefully and get 93% of accuracy. So I think the main challenge part is try to get the feature set. So that is the first work I did. And second one called designing and evaluating the clustering system for integrating patient drug outcomes. So I think it's kind of a long topic, but I just try to explain a little bit. For example, every day you go to online communities, you want to find some of the drug or some of the medicine, you want to see how good it is. And right now, the most thing you can do is try to scan and try to read each piece of messages one by one. It is very inefficient. However, if we have a way to integrate all these drugs into some of the aspects to see people's opinions on that. For example, for aspirin, if you want to take aspirin as a consideration, if I get a headache, I want to know people's opinions on aspirin's usage. Am I a good fit on that? Or I want to see people's opinions on aspirin's precautions, what things I need to care about, and treatment, dosage, as well as maybe side effects, all these kind of aspects. If there is a kind of summarized information we can extract from a bunch of the personal messages, which should be very effective. So my work can be summarized by this graph. First, we have the Yahoo messages, which organized by each specific drug. And we do the previous classification and separate them into news, spam, and user comment. And we split, we eliminated the news and spam because that is not what we really want. And after that, we do refine and extraction, put some of the useful sentences from the user comment. Here, another kind of machine learning techniques are applied is we should figure out what kind of sentences from the user comment are useful and what kind of sentences are non-useful. So we train another model to clarify. And we get a lot of common units with the collection. Based on some of the expert comments coming from the PubMed Health as the seed, we train semi-supervised clustering system using the PLSA topic model. And get outcome integration and separation, get our results. Just as I said, giving a specific drug, we will summarize each drug outcome into different aspects. Totally, usually it's maybe 8 to 12. Depends on the size of, depends on the numbers of the clusters. And for each cluster, which represent one aspect of people's opinions on top of this kind of drug, maybe it's about the side effects. We will see people's different opinions. And we offer another interactive system interface. So user, you can type in some of the drug you want, and you can take a look at this drug, and you don't really need to read all these messages. You just need to read the summary, and then you have your judgment. At the same time, we asked to verify our system. We asked some of the medical school students to be the judges and let them manually label this data and then try to separate all these messages into several aspects and then compare the results. Use that as the golden standard and then compare with our results. It seems like it's very consistent. So the outcomes for that is, first, we have very high performance to cluster patient outcomes using semi-PLSA model. The second one is very interesting. It's kind of extra bonus we found. We found some very unknown outcome, unknown extra like aspects. For example, this medicine, I don't know how to read it. I know, but I forgot. May help to relieve the burning mouth syndrome, which is it's kind of impossible for you to get this information read one by one, like messages. But we found that, and we got this proved by one of the medical professional magazine. And also we offer a very comprehensive evaluation framework with the medical students. So let's talk about the third project I'm working on. It's still ongoing because we're still polishing the paper, but I don't really have that much time to polish that, but it's still slowly growing. It's called the Comprehensive Comparative Effectiveness Research Hypothesis Prediction. So as I said, for example, if when we talk about breast cancer, there are maybe different kinds of treatments. Basically, we want to ask a question like chemo and hormonal therapy, which one is more effective? And this is the questions that the CER researchers in the medical area, they try to solve. So they will always go through very long-term and very costly clinical trials. However, actually, people's opinion are very important, so they can express something and they can tell the public their own opinions on this kind of different treatments, which is very easy to achieve and scalable. So we don't really need to go through the long trail like medical trials, but we can do this kind of CER prediction first and then make some pre-conclusion and make the long-term trial to verify. So there will be two main reasons why we do this. First is like we can prove some existing CER conclusions. The second is like try to predict some unknown CER hypothesis. It will be very effective for the real CER works. As I said, for the real CER, if you really want to know like to compare two treatments, you definitely need the long-term, like the clinical trials. But before that, you have many choices. But you want to try maybe 2 of them or 3 of them. And if from our analysis, we find maybe, for example, treatment A is definitely doesn't really worth to take a try. If it is our conclusion and it is trustful, you don't really need to waste money and waste time on this kind of treatment comparison. So it could be proof or it can do the prediction. And so our source is coming from MedHealth, which is a very professional, like the medical messages platform. There are a lot of doctors and a lot of patients there, and they discuss about their symptoms, their treatments, and medicines. We choose breast cancer and depression as our research object because they are very common disease, which also contains a sourceful input. For breast cancer, we compare chemo, radiation, and hormonal therapy. And for depression, we compare the meditation therapy versus drug treatments. There were 3 different trials of the drug, which is SSRI, SNRI, TCA. I didn't have depression, so I don't know what does it mean, but there are 3 different trials. The approach is we definitely want to analysis. We definitely want to the analysis of the preference and the sentiment analysis. The basic idea is giving a bunch of this kind of messages. First, we will train a comparison model. What is a comparison model? It is from maybe 1 or 2 paragraphs about maybe one breast cancer patient. She may describe something about the treatments she have already taken. First, we will build a model to select all the kind of patients who wrote this kind of message and then took at least 2 of the treatments. So that is a comparison, right? They need to at least the chemo and the radiation, and then she can do the comparison. So we should build this kind of model by some of the training. And after that, we will extract the sentences which have the hint of the comparison, which is very difficult. But we have a large amount of data, so we choose maybe 30% of them as a training. And we build up a very good comparison model which can give us very good outcomes of all the sentences or paragraphs which involves comparison. Another thing is a semantic model. For example, I give you a sentence saying, oh, I like A, but I don't like B. So there is a very significant preference saying I prefer A to B. But it's just a very simple sentence. People can have different kind of ways to say this thing. So we also need another sentiment model to giving an input and output will be showing people's preference. That also needs to based on the training and also the testing. Besides that, we also do the demographic analysis, which covers different gender, different age, and the location, which tries to answer the question like, which treatment works best for whom? Okay, so here are some results. Things we cannot predict the future thing. If something we found here, there is no future clinical trials. So we can only do the first thing, try to prove some of the current conclusions. We find this is just 2 examples that we found from our research. And then we compare with some of the listened. This is a very good England medical magazine. We find all the improvement, which means it's very consistent to our discussion, our discoveries. So which means like personal messages, medical messages are really, really informational, and machine learning techniques can help us to discover, to explore, to find some very good things. Okay, that is the skeleton of my PhD thesis, and I may take a little more time to talk about the things I learned from the industry. My first job was at Twitter, and I was in search and the content team. So there were 2 things I used machine learning techniques a lot. One is I work for who to follow team, which will give you the who to follow recommendation. Giving a user, we will decide what kind of persons you probably follow. So that involves this very kind of secret, but you can imagine we will build kind of user model and people model and then do better matching. And another thing is I'm very proud of because I built up by myself, which is the user interest, specifically TV sports detection and prediction. We're trying to find whether a user is interested about TV or whether or not people interested about sports. And also we want to tell user which kind of TV shows he may be interested in most. So we can give more this kind of TV related or sports related information, tweets to that user. And right now I joined Thumbtack, and there are a lot of space for machine learning to do here. There are just 2 examples. First is for someone who don't really familiar with our service, we try to give the customers the best practice to find some local services. And the giving request, and we will find pros to help you to finish your project. So there is a question, how to do the better request and pro matching. We will giving request how to find the best match the pros. That could be solved by machine learning techniques. The other one is the relevant project recommendation. For example, today I hire a house cleaner and I finish my job, I'm very satisfied. But sometimes some tech wants you to come back again and then find other projects. So we may say like people like you who hire a house cleaner will be probably maybe hire a DJ or hire maybe another guy or some of other categories. So we try to find this kind of relevant recommendation, which is also very challenging, but could be very useful. So as I said, machine learning techniques is everywhere. If you really want to know more, you need to explore by yourself. Okay, that is just my talk, and thank you. If you have any other questions related to my work or related to my research, just email me. Enjoy your night, thank you.